Hello, Casey Lai. So I lead product management and global sales for Primary Data, and we're going to show you our product, the DataSphere product, from a user interface perspective today. And hopefully we'll be able to actually illustrate visually what David's talking about with this notion of objectives and how it's actually implemented. And so a lot of the questions you guys had asked in terms of how to actually specify these requirements, how are they visible, how to define them, as well as the price accounting question that this gentleman asked over here, that will also be encapsulated as well. So before we get started, I remember Steven said I had to stand behind this line because if I go too far, I look like a zombie. And this is going to be tough to do because I'm going to have to be going in and out. So for the people watching, I'm really not a zombie. So you can see the flesh color changing. That's my disclaimer.
You're about that big because we're all looking at the screen.
All right, fabulous. So before I get into objectives,
and zombies are hot now anyway.
That's true. That's true. Who watches Walking Dead? Anyone? Right? Loyal fan. Okay. So before we get into the objectives, what you're seeing here is the dashboard, and this is the home page where we want to show you just a couple of concepts. The first one you see is this chart that says 99% data compliance. What this is just showing you is a high-level view of, based upon the policies and objectives that you've defined, how accurate are they in terms of ensuring that your data is actually getting the needs from the underlying storage that you have. And matching that with how much data that we've actually moved so that you can actually see the effects of data mobility in action. You also get to see a global view from a storage capacity perspective. So if you think about a lot of us are now trying to build scale-out systems, but also the power of primary data, as David mentioned earlier, is not having to pick a storage silo, not having to be beholden to one particular vendor. Well, the challenge is now you have multiple storage vendors. You actually want to see and manage storage in a global view. So here we actually show you that you have 484 terabytes globally across all the different storage arrays you have. Dell, EMC, NetApp, even cloud or object-based storage, and of which you've used 275 terabytes, and out of the 275 terabytes, what percentage is really active, as shown by the red bar, medium active, shown by the orange bar, and somewhat active, shown by the blue bar. We can also allow you to customize key applications that you want to see and get a high-level view and say, based upon my key applications, number one, how am I doing in terms of my compliance to my objectives? How is the performance of those applications? So let's get to the objectives portion, because that is what we spend a lot of time talking about, that David has illustrated. This notion of objective-based data management. And quite simply, for us, that means creating a uniform, standard, and consistent method to actually define the service level objectives you have for your applications and matching it to the capabilities of all the different types of storage arrays that you have. So let's create one here, actually, so that we can illustrate what we're talking about here. So going here to our screen for objectives, and we'll call this the SFD8 objective. So we'll come back to pricing in a minute, but you remember earlier David talked about having two major components when you're defining objectives, and that is performance and protection. And so think about what this would actually happen in the real world. An application owner can actually come here and actually define, with fine levels of granularity, specifying exactly what level of write performance or read performance that this application needs. So for example, if I'm an application owner, I can specify the exact number of bandwidth, the exact number of IOPS, and the exact number of latency I want for my application at an application level, share level, directory, subdirectory, folder, and even down to a specific file level, dictating that this is what I need to service my particular application.
Is there an API for doing the same thing without doing?
Yeah. Yes. This is available through CLI. So I did that for write performance, and I can do the same thing for read performance. So now that you've defined performance, there's many ways that you can address your performance needs with the different types of storage you
that
have.
performance interval, I'll call it, was dynamically determined by a storage catalog that exists in the site?
So once you set that performance objective,
No. I mean, the width of that line was, something from 0 to 10,000 or something. Was that based on the storage catalog at the time?
This is based on roughly the dynamic range available in the industry today.
yes.
Oh, on the industry
Yes.
level, okay.
Yeah. What you're seeing here is an older version. The newer version uses sort of an exponential scale because you don't need too much precision, but you do need a wide range. So it allows us to span from, like the one that has the biggest dynamic range is latency. And there we go from second scale down to hundredths of a millisecond or tens of microseconds.
You need to push it out to minutes too.
There's a different objective. It's not represented here, but there's a different objective when it comes to offlining and onlining of data to like a cloud service.
Yeah,
That's your recovery time objective. That's actually not in the demo, but in the and that one goes out to potentially hours, because if you're waiting for Glacier,
Yeah.
and that's used to say whether it's safe, whether it meets the objectives or not, to put the data on that storage. If it could take potentially hours to reconstitute it, then.
Yeah, because getting data back from Godot takes a long time.
But that's a distinction. Performance is assuming that it's online. That's how long does it take to get it online on a different scale.
From performance, is there most of an application owner, they may not know I need this particular amount of performance. I want it to be good, or medium,
So
an easier representation.
These basic objectives end up being in a little catalog of objectives with a name and a description.
Cool.
So most likely they're going to be choosing one from a list that says gold performance.
Right.
Getting down to this level of nuances for whoever is defining the objectives, and frankly that'll come from the factory with a number of them already defined that roughly match to levels of performance that you'd see, say, in a flash appliance versus a SAN versus a NAS system.
Precisely. So we're not going to expect the users to have to customize this every single time, every time they want. We will have predefined templates, if you will, things like for high performance or mission critical or for production applications you can actually apply those templates. What we're giving you the flexibility is to go in and modify it based upon your environment, specifically what you're seeing. So coming to protection, this is where you actually have some flexibility in choosing and defining what levels of durability, availability, serviceability, recoverability, etc. And like David said, this is not only an aspect of ensuring that you have the right level of protection, but this also affects pricing as well, right? Because, for example, server-side flash, all flash arrays, they can meet your different performance requirements, or maybe the same performance requirements, but at different levels of availability, right? So same thing here, we define it in levels of nines, something the industry is used to seeing. So for example, I can define, I want 4 levels of nines of durability, 5 nines of availability, 5 nines of fidelity. And there was an earlier question on replication. Well, this is where you actually get to define that I want to put my data on storage that's capable of replication. So for example, we have either storage that's only on-site and that cannot replicate, or you can define that you want to put the data on storage that can actually replicate. And similar concept when it comes to encryption, where you can set it for both in-flight or at rest.
So, Casey, what do you mean by fidelity? I think I understand.
We're changing how we name that. It's based on some of the feedback we got at the previous field day. A better way to think of it is just priority, and it's the priority of these objectives being met relative to, say, another piece of data with the same targeted objectives at a lower priority. If there's resource constraints, which one wins?
Okay.
And that also determines who's paying the premium, because ultimately the priority is no more nor less than the amount more that you're willing to pay to get the same thing, so that you're sure to get it even if there's a constraint on how much of it's available.
What storage out there provides 8 nines availability?
Well, the interesting thing is the number of nines can drive the replication. So also, because number of nines is really an expression on log scale, when you look at, if I have a storage system that does 4 nines and another storage system that does 4 nines, and
Together it does 3 nines, right?
if
Found out last time, right?
If you spread one object across both of them, yes.
if they're logically independent of each other, then it's the aggregate of the two. And since it's on a log scale, that means the sum of the two, because it's the product in the...
So with fidelity, is
So
that
think of that as
actually
priority. Sorry.
influencing what might be for recoverability and security, or just the durability and availability?
So let's talk about it as priority, because we haven't updated the name there. When something has a higher priority, if there are limited resources, i.e. the storage systems capable of meeting those objectives are running out of space, the ones that get evicted first are the ones that have the lower priority.
So there's best effort, bester effort, and bestest effort?
That's right. We're actually rephrasing that priority as just
Best of effort.
low, medium, and high.
Yeah, unfortunately, too many other people use priority to mean performance level.
Yeah. But it applies to...
Well, it actually does, though, in a sense, because this is your priority of
Only
meeting
when
your...
constrained.
Yeah, because if there's no constraint, then everybody gets it. So by definition, priority comes into play only when there's a constraint. Otherwise, lower priority guys get just the same.
But it applies to protection characteristics,
It applies to all.
performance, write
Yeah.
performance, and cost. All the characteristics
It does.
are effectively...
It does. But there's part of this is not being seen is that the pricing, as you pointed out, an important part of the pricing are the penalties for not meeting the objectives. And the penalties are what are shaped on a per dimension basis to say what is the net financial impact of not meeting this specific protection dimension versus this performance dimension.
So I can have a penalty beyond, I'll give you a new roll of film when I lose yours because I'm developing it?
I didn't
There also needs to be
You said
something... Go on.
you said that you can place data on a storage that is capable of replication, but it's quite complicated mapping the LAN that you get from the storage to all the data that you're mapping on top. So how can I manage replication of that LAN of that array?
Yeah, the replication is actually handled within our data portal layer, the same way the synchronous mirroring is. So,
it's not about the functionality.
it's not about the functionality of the underlying storage.
Okay.
The underlying storage can aid in that, and we can tie into it as an accelerator. For example, like on cloning of files. And cloning is one of the things that you need to do to be able to make an async image replicated. But even without that capability, we can replicate, asynchronous replicate, or snapshot and destage those snapshots.
So you don't
It actually
the
takes all of
replication
these things and
features of
folds
the
them
array.
into the same concept. These are alternate copies of the data, and it's just a question of, are those copies synchronous or asynchronous? And if they're asynchronous, what are the recovery points? How old are they, or what's the schedule on which they're made? So all of these recovery points, whether they're images that are kept synchronous or ones that are asynchronous at prior points in time via snapshots or async replication, get to think about those all the same. And because they have their own set of protection objectives, they don't have performance because they're not live images, but they have their own protection objectives. That's what drives the selection of where they get placed.
So this leads to another question about the fact that if you have multiple data centers, you have to deploy the metadata engine on each one of the data centers.
In the initial product, we're going to support really just 2 zones, on-site, off-site. But down the road, we're going to support full zoning, where you can declare zones and where the data constrain it to specific zones. And then within that zone, the placement is based on meeting the objectives of the data. So the zone becomes an objective, and it within the zone, the objectives dynamically determine placement.
So how far will that scale? Would you be able to make those zones to a rack level?
Yes. And to an individual node level. As a matter of fact, and one of the reasons I was reluctant to introduce zones in the initial product is because it could be abused. to where you define each storage node as a zone and put in the objectives which zone it's in. And then basically you're managing manually the precise placement of data. And you could use it in that, you could have used it in that fashion.
So from a snapshot perspective, you seem like you're using the storage underlying capabilities to do those sorts of things.
Yes, the snapshot of a whole share, that's mostly a metadata thing, but when it comes to doing a copy on write clone, we can tie into the underlying storage to make that space and time
But from a
efficient.
replication perspective,
We're doing that.
you're doing everything at the higher level rather than allowing the storage itself to do it.
Except for we can tie into the cloning capability of the local storage to make a quick
To
fork.
help clone,
Yeah.
for asynchronous replication.
So really we're only tying into the cloning underneath and then using that to build snapshots at the whole share level and to build replication and other things from it.
For compliance
Because
requirements.
that's the essential piece, is to do a copy on write of the block mapping in a capacity and time efficient way.
And when you say cloning, you're talking about read-write capable copies, not just read-capable copies.
That's right, a full clone.
How are you mandating compliance? Let's say encryption at rest compliance or anything of that sort for PCI 3 or HIPAA. Where in this can I say this must be encrypted?
So
No fidelity, no other option. If we don't get this encrypted, we're getting fined or sued.
that would ultimately come in the shaping of the penalty side for saying that this security dimension overrides, which is why ultimately we need to have the penalty be something that can be adjusted to say this takes precedence over anything else. And there is actually this notion of a penalty that is so dramatic that to the system it means it's better for the data not to even exist or not to be considered that there's enough space for it. Return Eno space versus let it be somewhere else.
How difficult is that to implement?
It's more about the user interface and how to describe it there. The implementation down in the placement machinery is actually relatively easy. The reason why we don't introduce those in our initial products is we need to find a way to make it simple enough so that people who care can go in and do that, but make sure it doesn't ruin the elegant simplicity of the rest of the thing.
Like a checkbox.
Yeah. Well, and it would really come into say a way of saying that this dimension is of such high an importance that failing to meet it would be not just mean that would be dramatic enough, have a high enough quote penalty that it's better to return Eno space. So it could be, and we did play around with this, putting on each of the dimensions a rough way of saying what his value to the overall is. Because in the end, when the financial arbitrage engine, which is determine where to place things, it kind of needs to know the partial contribution of each dimension so that it knows which ones to sacrifice when and whether it can. For now, we're trying to keep the UI very simple, but these are all very valid questions.
And the allocation event happens when like a VM is defined or a Linux application is described, or
So when a file is created, it gets objectives that
Based
it
on its
inherits
directory?
from the parent directory, and those objectives may be smart objectives, which we're going to go into in a minute, which discriminate based on things like file names and parent directories and stuff. So it can apply the objectives in a smart way based on the actual situation. So upon creation is when the initial placement is determined for the file.
yeah, so LUNs don't necessarily have that sort of hierarchical description available to them, right? So I mean, yeah, files are within a directory, which parent directories and stuff like that.
So what we're doing is we're taking and we're elevating everything to a file system kind of view. So where you have right now LUNs that are floating in the ether,
Yeah.
you know, what's the namespace that LUN exists in? We're tethering all of them within the namespace and treating the LUN as a file. So if that LUN file actually is living on a SAN, then by the time it comes out of the client, it's going over Fibre Channel just like it did before. But I've basically put its handle, the LUN identification information, is now
In some sort of file.
it's in the namespace. It's in a file system, so you get all the convenience of the file system namespace manageability, but the file could represent a LUN.
Okay, now you got me thinking I want you guys to be a Vasa 2 consumer as well as a Vasa 2 provider.
Well,
We are a
don't
provider.
need to be a
I know
consumer
you're a
because we take,
provider.
Yeah.
but we don't have to consume the Vasa 2 because we can
But
use the underlying storage even though it's not Vasa aware.
But you have to code to every, if I'm going to use the storage system snapshots, then you have to code to every one of them. It's just as a standard API.
But that's just an accelerator on our part as a way to find a semi-normalized API to go and get the snapshot.
Yeah, no, I'm just,
Yep.
we,
But you're exactly right.
And a lot of them have their standards-based snapshots protocols that
What, a
exist
Vasa
in a lot
2
of
client
arrays.
as well as a provider? I mean,
No, so that we
Yeah,
can
if-
consume, we
if
can use the
primary-
Vasa
if primary
interfaces
data was a
underneath.
Vasa consumer as well as a Vasa provider,
Yeah.
then they could leverage snapshots on any storage system that supported Vasa.
within VMware.
Yeah. Well,
Well,
no,
outside of VMware.
And even make it available outside of VMware. But right now,
they would look to the storage array as if they were
VMware
vCenter.
host, yeah.
But right now, we've just implemented the vendor-specific calls to do that. But it would be better to say Vasa 2 is the normalized way to do it, and we use them.
Yeah. Let us have a standard API, even if we have to live with VMware defining it.
Yeah, I think one of the challenges for your system would be, if a client is sitting there and has purchased, let's say, VNX or NetApp storage, they're kind of getting used to all the capabilities and characteristics, functionality intrinsic to that native storage environment. And you're going to sort of abstract all of that and sort of control it, and you're only going to really use cloning and or block store
So
effectively
we're taking the data services layer that's right
out
now
of there.
fragmented and unifying it in something that's vendor agnostic and done at a higher layer that allows things like the replication to happen cross vendors or even the synchronous
heterogeneous,
mirroring.
yeah, I understand it, and mobility is all great and all that stuff is good, but
But it does mean that where they used to be interfacing to the data services UIs and
device,
stuff
yeah.
on the device, now it's at a different layer. Luckily, VMware's already done this for us. At least for that
Vasa.
VMware environment, they're already used to doing it through.
yeah, I would say so, but from a usability perspective, but Vasa actually provides the capability of utilizing those services at a native potential for the
That's right.
storage,
And
rather than a higher level, homogenized version of that.
but they are homogenizing the user's experience. And under the covers, it's adapting to the differences. And what we're doing is we're leveraging those same things, like the underlying cloning capability, but things that are at more the metadata, like snapshotting the namespace. Well, it turns out that's not even in Vasa 2 or in VMware because VMware only asks for clones of files.
Right.
In other words, they're only using a narrow subset of the services below anyway themselves because
Yeah, but I'm more concerned with replication and things of that nature, which are pretty high cost services and high
Yep,
profile customers want to use them because of the high
And
availability.
what I want to do though is actually change a little bit the mentality so that those two are thought of as objectives and you're thinking, what is my intent here? What is it I'm trying to achieve? I want to have images in time that I can go back to in case the application or a user corrupts it. So speccing what these alternative prior image in time, how they're made, when they're made, where they're placed, and doing all of that within the same language of objectives is actually a pretty massive change. It's a way to renormalize what right now is done in a very fragmented way and more done procedurally and speccing process versus declaratively and declaring what it is you want. So I'm trying to make those things from procedural manipulations to declarative manipulations in the
But
objective.
even with that, if I have arrays that are good data movers, I want to use that data mover. I don't want you to replace that
Absolutely. Absolutely. And that's a matter of tying in more and more to leverage the services the services that can be used.
The native services of the storage machine.
Right.
Yeah.
But I just want to be clear, so we don't break or stop the native capabilities of the arrays, right? So for example, if an array has dedupe,
The
we're not going to
challenge is
stop the dedupe
once you
from functioning.
intrinsically introduce data virtualization, mobility, and stuff like that. If I was replicating the LUN on some SAN and you move it to some other device, it's no longer being replicated.
But there's two ways that you could think of that replication. The replication could be a capability encapsulated with that data store that improves its availability, durability, et cetera. So it's encapsulated underneath us, and that still works. And because when we place data on data stores, we also put the metadata there so that it's self-contained, meaning that you can recover from it. It's actually a viable image. So there's two ways to think of the disaster recovery and async replication. One way is it's encapsulated down in the storage node, and when data's on it, it's getting it inherently, versus being handled up at the data virtualization layer where it's driving the asynchronous replication itself.
Correct. And also think of it as
some
a
level,
complementary as well.
I hate the thought that I'm actually going to say this. We want you to be the single pane of glass, and so I want to say here are my requirements, and have you do provision the LUN, tell the array that it should replicate.
Well, if you buy into moving that logic up, you have to do that.
Yeah, well, I mean, right now I'm creating a LUN, the model is I'm creating a LUN, I'm setting up the replication, and then I'm telling you that it's a replicated LUN so that it provides that level of capability. And I want you to be one ring to rule them all.
Yep. Our general methodology has been to ensure that we have that data service implemented in a way that is independent of whether the storage nodes underneath are capable of it, even though that may be slower, and then to accelerate it by potentially tying into native mechanisms. Snapshots and cloning is an obvious one. Data moving is an obvious one. Setting up asynchronous replication and such can also be done, but it's a lot more nuanced at that point.
Right.
But yes. Okay.
So this is the aspect of pricing that we're talking about. So in addition to setting the objectives for performance and protection, if you had competing resources, for example, how would you have a way to arbitrage and determine, who are going to get access to those resources? So, this is one aspect is if you had a chargeback model within your environment, or start thinking, at least in this concept of there is a price or a penalty, as David called it, right? If you wanted to consume these resources, how could you try and characterize and prioritize your applications? And so price becomes yet another lever that you can set, and hopefully you guys can see this in the back. So we have different characteristics of dollar per file, dollar per gig, and then on the performance side.
$5 a file is definitely going to encourage shadow IT. That better be a log scale, because I want 0.05 of a cent per file.
And this is, of course, the value of meeting the objectives in their entirety. This is upon compliance, meeting the objectives. The penalties for missing it, those are the ones that are shaped more on a per dimension basis. And these could be used to where you're pricing it solely on a per gig or per op, or you don't have to use all of them. They're just different ways of rating it.
Correct. So that takes care of objectives. Now, unfortunately, human beings are not flawless, and we're not perfect, and we don't know exactly what we want all the time. And so we've built in this notion of, how do we protect people from changing business conditions? Or, let's say you have an application that behaves differently at certain times of the year. Black Friday, or registration, if you're a school, there's certain events or payroll that are scheduled where it requires either more or less resources. And how do you give yourself that flexibility without overconsumption of the resources you have, or under provisioning of the resources you have? So we've created this notion which we call SMART objectives. And you can think of SMART objectives as our mechanism to do exactly that, give you those levers of protection for the changing needs of your business applications. So I'm going to call this one Howard. And
okay, but it's going to be a loudmouth.
And under the SMART objective, you can actually get more granular and actually define a specific data type within the application or the share. So here, let's say I only care about an objective for VMDKs within Howard. So I'm going to say I want to use the basic objective we just created for everything in this application. But if there's a VM decay, I actually want to treat it a little bit differently. And so here we see, first thing we can do is we can say that, based upon certain conditions, sometimes these VM decays can get a lot of performance. Not all the time, but when it does, I don't want it to drag down the other systems, the other applications, or I don't want my users screaming. I want to have the ability to then dynamically move anything that has VM decay to storage container that we've designated as high performance, or you've defined as capable of meeting the requirements of high performance. So with that, you are still adhering to the basic objectives for the initial placement of the data. However, once this happens, a trigger gets alerted, and the data is then automatically and non-disruptively moved to the high performance tier.
Now I want a bit bucket. All MP3s go directly to bit bucket.
You can do that. You can define it as .mp3.
You define the durability on it to
durability. Be... durability -1.
And it needs to go both ways, right? Because, for example, holiday season is a great example. During holiday season, I might want to dynamically move things to a high performance array or location that's capable of sustaining that load. But what happens after January 1st? That load is not going to be the same. Do I still want all my data occupying the most expensive storage assets I have? Well, this allows us to create a cooling schedule where we can say, if we see 124 days of inactivity, for example, then I want to dynamically move the data to
It's registration
low
if I see
performance.
2 days of inactivity.
Or 2 days if you can be aggressive, yes. And the same thing for snapshots, you can treat them separately as well, because snapshots are a protection mechanism. So you can treat them with different levels of prioritization in terms of cooling and also in terms of promotion. And you can add different patterns. So, within this, you can say, I also want vswaps or dbf files. We allow you to add multiple patterns within the smart objective. So now I've created that smart objective. Well, now it's going to make me add it. So once I created Howard, for example, what David was saying earlier, normally by default, every child inherits the objectives from the parent. However, you actually have the option of saying, if I know a child needs a different level of objective, different needs, I want to have that flexibility. So we can go here to a specific folder and say, I don't want you to inherit SFD8, I actually want you to inherit Howard. And now you actually have a parent and child having different levels of objectives.
Or the smart objectives, different machinery selecting different objectives at different times.
Precisely. So that takes care of the notion, the illustration that we're trying to show you in terms of objectives and smart objectives. We'll go to the infrastructure side, where we'll show you in a single pane of glass all the different storage types that you have. So file-based storage, block-based storage, object-based storage, and the percentage of capacity utilization as well as available capacity, both for that specific device as well as globally across the entire environment. We can also give you a more detailed view from, I don't like the resolution on this one. I'll make it better. A detailed view of all the different shares, but it will actually show you, from a share perspective, the level of performance, IOPS, bandwidth, and also available storage.
One thing to note on the objectives is that in a VMware environment, those objectives show up as policies within vSphere. So you can select gold performance on your VM, and that will automatically, through the Vasa provider, set it on those specific files. Cool thing is, you can set smart objectives from within vSphere as well. Whether it's a smart objective or a basic objective doesn't matter. So you could set an objective which adapts based on level of activity or how long it's been closed, so that it automatically gets demoted if there's need for the resource when that VM hasn't been active or hasn't had a sufficient level of activity recently.
That's a good point.
Once you've built all of these objectives, the smart objectives and basic objectives, like I said, and that'll come from the factory with a number of those. From vSphere, it's just a matter of selecting the right ones.
Right, so the vCenter admin actually doesn't have to even log into primary data or see what's going on in primary data. They're going to be doing the same tasks they used to do. So with storage-based policy management, they're used to selecting policies, gold, silver, bronze, etc. The backend, which is primary data, is defining why it's gold, why it's silver, why it's bronze, but it shows up naturally for them. So it's a very tight integration into vCenter.
Are you still limited to 256 shares per your namespace?
Actually, we're not. So those limitations that you have traditionally for traditional file systems, like shares and snapshots, they go away with us. So there's some very interesting implications there, especially when you look at vvols as well. This guy's nodding. He knows what I'm talking about, where you could actually have some serious limitations because of vvols on the number of VMs per LUN, for example, which could significantly drive down the utilization that you have once you get rid of that limitation.
So even outside of the VMware world, it's more than 256?
Absolutely, yeah.
All right,
Yes.
Your collateral hasn't been updated for that.
Yes.
Yeah.
Are you supporting vvols from your GA release?
Yes, we are. So we'll support both vSphere 5.5 and vSphere 6.0 with vvols. So one of the interesting things about vvols, as you know, is we think it makes a lot of sense, right, for storage to be VM aware. But to get the advantage of vvols, your storage array, that specific model, has to be vvol certified. Not the vendor, the specific array. And so if it's not, you have to change your array. So there's a forklift upgrade there. And two is, if you think about the power of vvols, and that is being able to now with policies define for each VM what level of not just performance it wants to get, but data services across the different storage arrays that you have. Well, that works if you have a heterogeneous storage environment under your ESX cluster. The problem there is if each of those arrays have to be vVol certified, that means each of them has to be a Vasa 2.0 provider to VMware, which means each of them is saying, I am the master storage entity. The problem is then when you create a VM, how does that VM know where it needs to go?
There's
if you have
arbitration
multiple
within the storage
masters.
and arbitration between.
So that means the end user, has to get involved to manually determine where it actually goes. With primary data, we are the master Vasa provider, so two things happen. One, you don't have to manually decide. The objectives and policies decide where it actually needs to go. But two, because we've abstracted the Vasa 2.0 provider capability, the underlying storage doesn't need to be Vasa or vVol certified. So that means you get to A, keep your existing storage, but B, mix and match different storage, whether they are vVol certified or not. So giving you a lot more flexibility now in terms of costs, data services, performance, etc.
Where's your provider running from?
DataSphere.
So since DataSphere can be a VM,
Yes.
how are you preventing the VM from being put inside of a Vasa provider, which could be like a catch-22 or a data loss if the host ever goes down that owns it?
So you're talking about the availability of
Yes.
DataSphere. Okay. So we have inherent HA capabilities built in to DataSphere. So if one virtual appliance goes down, there's failover capabilities.
Jared was more, how do you protect people from being so stupid as to storage vMotion the VM that manages the storage onto the storage that the VM manages? and the answer is you can't fix stupid.
Don't laugh.
I was going to say.
I have seen customers
fix
do that before.
You've seen them do it?
I've seen that happen before
Yeah.
with VM-based Vasa providers.
Yeah, it's one of those things we need to look at. How do we lock them out of so that they don't accidentally try to do it? But in reality, if they're deploying DataSphere as a VM, there's going to be some performance implications to that, and obviously they need to choose high quality storage. The protection and performance of the storage that it sits on needs to be, the highest, since this is the metadata.
Jared, you ever seen anybody do that more than once?
You'll learn quickly.
Yeah, there you go. Sometimes we need to get burned once.
Yeah.
Okay.
What happens if you lose the VMs?
If you lose the DataSphere itself for whatever reason, DataSphere has in it like 4 levels of safety checks, right? One is the synchronous mirroring between a couplet. So 2 data spheres can replicate for each other, or 2 different nodes. So you can start with parking it on a single VM as a single node, and just depending on the high availability and the good protection of the underlying storage so that you don't lose the VM in the first place. The second one is to set up a couplet that are replicating for each other. The third is that periodically that data is asynchronous replicated to potentially an offsite copy. That's third. And then that offsite copy, once it's async replicated, can be archived as a backup. So using durable storage and good reliable storage under it in the first place, replicating 2 of them synchronously, the asynchronous replication and the backup. And the fifth and final fail-safe is that DataSphere is periodically posting the metadata out with the data.
Okay, so I can re-ingest it? And
So if you have a crash, it can re-ingest it. Now that posting is done lazily, so it can obviously be somewhat out of sync. But that's sort of the scorched earth. You're having to go back and recover after nuclear disaster, and all you have left is this one storage container. The last thing you want is a bunch of ethereal objects with no identity.
Yeah.
And this makes sure that you keep it there. That's also the mechanism by which we can have things that are posted up in the cloud be self-contained enough to call that a true viable backup.
Okay.
And displace the whole workflow of backup and archival as something that necessitates having a separate namespace and having to map your catalogs together and all that other bullshit, because now the thing has the catalog with it, self-describing, et cetera.
The other thing to note is, so DataSphere is never in the data path, right? We serve metadata. So worst case, if all those 4 or 5 things that David talked about still didn't work, all read and write I/O still continue. So they still go between client
Unless
and
you try to
storage.
open or close the file.
Even,
So just don't shut down the VMs
Just
until
don't
you
close
got
the
it sorted
VMs,
out.
right, yes.
But what about option 4 when it is running as a gateway for those Windows 2003, 2008 hosts, iSCSI?
So the
that.
gateway, when now you're talking about not stability of DataSphere, but the DataSphere Extended Services VM here.
No,
And that thing is
I'm talking about like
this DSX here.
physical hosts,
Yeah.
things like that. Do they still need to connect to one of those
So
DSX?
the DSX is stateless, so those can be brought up anywhere. But if you don't have one, then if you can't go through the legacy protocols, and you would need a native portal inside the OS. Because there's actually in this world you could load in your guest VM the native portal and bypass having to go through all of this.
What about physical hosts?
What's that?
Physical hosts.
So this physical host,
If that was like a Windows 2003 box.
this whole box goes down? Or you mean it's not virtualized at all?
Correct.
Okay.
Because there's still a lot of that out there.
Yeah, there's 2 modes to be running a bare metal physical host. One is with the data portal as a native client.
Okay.
And in that case, it's a filter driver inside of Windows.
Only
Or-
2012.
Yes. Or
2003 or
it's-
2008, what are we going to do?
then it's talking to a portal. And one of the things I didn't say is that DataSphere has sort of a fallback DSX running alongside. You wouldn't want to use it.
That's the gateway mode.
Yeah, and you wouldn't
We
want
might
to use
not want to use it, but is there anyone here whose customers are 100% Windows 2012?
No, you would want to use it, yeah.
But,
So you'd
but
have
then
to-
again, expecting somebody who hasn't shipped their storage system yet to support a version of Windows that Microsoft doesn't support anymore is a stretch. So I'll give you 2008, but 2003.
But the point is that you have to have a DSX with a data portal running that can service the legacy.
So in those cases, let's say we had a fire in our data center.
If push comes to shove, DataSphere can do it for you because he's running those same services. So he is his own fallback for it. But you would really want to distribute that gatewaying functionality.
Yeah.
And that's where, yes, you'd have to make sure that
if we had a
service stays
fire
up
in our
somewhere.
main data center and we were doing the protections, doing SAN replication somewhere else, and we did have a copy of the DSX or DataSphere over in DR, can you map destinations with where the data was replicated to? So we can bring
again-
our VMs up and just have them mount back to where they were replicated to? How does that DR
again,
work?
DSX is stateless. So wherever you bring him up, he can provide the portal into the distributed data space.
Well, the thing is, like, we don't know where you guys are putting all of our data.
Right. So the data
Prod goes down, DR comes up. Where's our data? How do our VM copies know where it is?
You have to start DataSphere, and DataSphere has built in the portal service, or you could start the portal services on the network. That's more scalable, but either one of those. So really, the only thing you have to do is start
doesn't
DataSphere.
know that line mirror whatever on this DR NetApp is where our data is, and is it going to be bringing that
the old
replicate
DataSphere
online?
the old DataSphere used to know. So basically, the original DataSphere had all the mapping of all the different storage and where everything's mapped. That one goes down. You want to make sure the new replicated DataSphere, when it comes up, it keeps the same namespace structure and everything, right?
Yeah, considering
like I said,
we're replicating, snap mirroring, whichever doesn't know about that, is it going to see it? Or are we going to have to go through a manual process of mapping all this data?
So again, the first layer is to have DataSphere sitting on storage, which is highly available and potentially replicated offsite, so you can start DataSphere
That's
from a
fine,
replica.
but
If you don't have that,
on
DataSphere
DR,
can do its
after a
own.
fire and prod, what are the steps?
So if you have a scenario where you've lost these, 3 levels of parachutes, then you can always go to the storage containers themselves and extract the metadata and rebuild what's needed for DataSphere to start again. So if all I have is one storage container that was just one of many containers, and DataSphere and all those other containers are gone, and I have this one, or I have a few, I can run a tool that'll collect that metadata up and give you what you need to start DataSphere so that you can
And it
use
would
that
have
stuff.
all the history of everything.
Or actually could unwind it and take and reconstitute that data, put it back in a flat fashion to where it's normal, as if primary data didn't exist. Put it back in a share.
So
with
it's
all
not
the metadata.
as instantly available as just bringing up a snap mirror, booting the VM from it.
If you can't do that with DataSphere, then no, it's not that fast to do it with. You have to be able to bring DataSphere up, or you have to go through and recombine it with the metadata so you can use it without DataSphere.
So does your metadata include the names and locations of the replicates?
Yes.
All right. So if something's snap mirroring, if something's going through recover point,
That information would in the
the terminal location is there. Okay.
in with the DS. Yeah, basically all of the descriptive data, all of the metadata with its objectives, with information driving the replication, et cetera, all that's posted in the respective storage nodes that are holding those objects. So if push comes to shove, you could recombine the data with its metadata and start without primary data there. We've actually endeavored to make that a human readable form that's scriptable, so the tools to actually do the reconstitution are just scripts.
Yeah.
And really all it's doing is take it from an object form where you've got these blobs and putting it into the hierarchical namespace with all the right names and permissions and stuff in it.
So does the storage underneath the DataSphere data portal have to be fully devoted to DataSphere services, or
No,
can it
you can
be
carve out a
arbitrarily-
single share, you can carve out a
We're
single
not,
run.
it's not an all or nothing model, so you can
Not
still.
either or, so it could be potentially a way of migrating data from one form to another over time.
How that's going to interact with our performance modeling and the adapting to load that's not under our purview is an interesting question. So for simplicity's sake, right now we're saying, that that's a corner case.
So that's a good example. So for example, Ray, to show that if I were to add a new storage, for example, and we will go and detect the available storage that's on the network and say, okay, show me what you have and let me determine what I want to add. And so I get to select, specific volumes or, LUNs that I want to add. So it's not a all or nothing, right? And even then, I could say, do I want to import the existing data or do I not want to? So you do have the freedom and flexibility, so you don't have to dedicate the entire array to being underneath primary data.
And with NAS anyway, it's actually very easy to assimilate on demand the data that's already in the share. So it can look as though it's live immediately, and it copies the data over lazily and on demand, so that the apps can immediately start using DataSphere to access those existing shares.
Meaning you don't have to wait for 5 petabytes to be migrated before you can actually start using DataSphere, right? So it's a very
You're almost assimilating the metadata to some extent. You're importing the metadata, and
We import the metadata and leave the data in place without even copying it. But to take that a step further, the metadata itself is copied lazily and on demand, so it looks like the metadata has been copied already, even though it hasn't. If that makes sense.
yeah.
So it becomes a very easy solution for data migration, either crossing vendors, different protocols, et cetera. So that becomes a nice use case for primary data as well.
How are you auditing your moves or logging them and reporting them?
So what we're doing is we're keeping, oh, you've got it here?
So yes, so here, every action that's done in DataSphere, who did it, at what time, and the progress is always captured in an activity log. And you can customize
That's down
it.
to the file touched level.
Yes.
Yep, down to the individual file level.
Yep. You can customize this as well. So that way you will always know, hey, someone did some data moves that they shouldn't have, someone created some profiles or some objectives that they shouldn't have.
And then how can that be exported out through syslog or log4j or any of the other formats?
Yes. It already is.
And then same with alerts. There are some pre-canned alerts that are set, but you can also customize and define your alerts as well. So I want to be alerted when data movement takes this long, or I want to be alerted when I'm running out of capacity, et cetera. Those all can be customized as well within DataSphere.
Okay.
So that's it from a demo perspective. Are there any other questions?
Just got one quick question about vVols.
Yes.
In terms of protocol endpoints, are you doing something similar with the DSX VMs where you effectively surface a local protocol endpoint for every host?
DSX is the local.
It is the protocol endpoint, yeah.
Right.
Those DSX VMs on each physical host, they are acting as a protocol endpoints. Yeah. Great.
Great question.
Thank you, guys.
How
Yes.
are you priced and licensed?
So we're priced on an annual subscription basis for the DataSphere, and then there's a small fee for a number of hosts that are connected to the DataSphere. So it's not by capacity, so regardless of how much data you have, that doesn't affect the pricing.
And when my purchasing department decides to pay your subscription renewal a month after the subscription expires,
We get your firstborn child. No. No,
he's 34.
You can have them.
So I think the question you're asking, Howard, is are we mean and do we just shut you down the minute we don't get the payment on time?
Hell no.
The answer is no. Right? We will alert you that say you're behind. Please contact.
Oh, you can send me
primary
annoying emails. You can call on the phone. Just like if the system stops working.
Right. We're not going to shut you down. We'll just let you know that you got to pay, and if you don't pay, you're not living up to the responsibilities of the license agreement. That's all.
And then I'll just go to hell.
Can we get Lance to say that on camera?